first question's the easiest one. Please tell us your name.
My name is Chuang Yin Nguyen.
I'm James Wang.
I'm Brian King.
I'm Alexander Coppins.
And I'm Peter Wang. Hi, I'll be starting. So college, it's an end for many. It's an end to the frivolities of high school, adolescence, prom, all of that. But it's also a transition from adolescence to adulthood. So we approach this problem as if we were college-bound seniors, ready to enter the whirlwinds of higher education. 3 questions came to mind. How much does it cost? What's in it for me? And will I be happy with my choice? The answers to these questions were truly surprising. We learned that plenty of free money is given out each year, that associate's degrees may not be the best for most, and that money can buy happiness in limited circumstances. So you may be wondering, why should you listen to us? Why should you spend countless hours of your time reading our 30-page report? Why is this the solution? And an important reason is because we took into account 2 very important facts of life. The first is that money today is worth more than money tomorrow. $1 tomorrow is definitely much worse than $1 today. And the second is opportunity cost. This can be best expressed in an old Chinese saying that my father taught me, 丢了西瓜,捡了芝麻, which means to pick up the sesame seed, you lose the watermelon. So in this case, the watermelon is the opportunity cost of picking up the sesame seed. So to figure out the cost of college, we first needed to determine the time spent in college, then the annual and total cost without financial aid. Finally, we evaluated the impact of financial aid on the cost of college. So to determine the time spent in college, we introduced a helper function, d of n, which represents the percentage of people who graduate in year n, with year 0 as a starting year. So, for example, year 3 is actually the 4th year of college. The values in parentheses are normalized to 100% to remove those who do not complete college. These figures were used in our calculations, but thanks to our propensity for typos, were not included with the report. While researching our report, we made a simplifying assumption that all people graduated in either year 3 or year 5, corresponding to the 4th and 6th years of college. However, we have since researched better data. As such, the values on the right are more accurate. For example, D of 4 is 15.9% instead of 0%. So with the college graduation rates, we could then take the weighted average of those rates to determine the time an average student would spend in college. In our report, this was calculated to be 4.68 years. However, with the newer graduation rates, it is 4.35 years. The cost in the 2011-2012 school year for college, including room, board, and other expenses, was $19,339. So with a cost and a time in college, you would expect, it's easy to calculate the total cost of college. Just multiply. But we realized 2 key things about this. First, this is a 2011 figure. It's 4 years old, and costs have increased since. And second, they will continue to increase throughout college, so you can't just multiply. So to model the annual cost of college, we first determined the historical growth rate. Then we extrapolated the 2011 figure to the present, yielding $21,825. We modeled the annual cost with an exponential growth function using the same growth rate and $21,825 as the starting cost. So with the annual cost and the balance of integration, which is the time, we could determine the total cost of college without financial aid. It was calculated to be slightly over $100,000. But before you pull out your handy $100,000 bill to go and pay for college, remember that colleges give plenty of free money and loans to people who need it. to make up the difference between the total cost and the total expected financial contribution. This helps lower income families achieve their educational goals. So financial aid is the total cost minus the total expected financial contribution. That seems like a lot of free money, and I'm sure that everybody here likes free money. However, it's important to realize that 27% of this has to be paid back. It comes in the form of loans. So we needed to add the value of the loans to the expected financial contributions to get the total student cost. So to do this, we assumed that the loan was a standard student loan. Federal Stafford loans have 120 months of payments. So we split the loan into 120 payments over 10 years and calculated the present value of each payment, which is the value of the payment discounted to the present. Then we summed all of those together and the expected financial contribution to yield the total cost to the student. So, what were all the R's? Well, the capital R is an annual 9.6%, which can be converted to a monthly 0.77%. This represents the cost of capital rate, which is essentially how much it costs to borrow money. The lowercase r represents the interest rate on the loan, which is 4.66% annually. Now you may be wondering, why do we use the stock market return instead of something like bonds or CDs or even treasuries? And the reason is because when you look at a career, you're looking over 30, 40, some people even spend 50 years. So the most appropriate return is that the highest that you can reasonably guarantee over 50 years. And the stock market has been shown to overcome its short-term fluctuations and even out in the long run, which is actually why most people invest in stocks in their retirement account. So this is a table of the total cost to the student. The average cost for a typical student is around $65,000.
Some students may consider going to get their associate's degree. Assuming the costs of living are the same as those of a four-year program, we can approximate the savings by finding the differences in tuition. We then use this information to calculate the total cost for 2 years to be approximately $34,000. Contrary to our 2-year assumption, many students take about 3.3 years to complete an associate's degree. This makes the cost of an associate's degree increase about 60% to almost $60,000. President Obama has recently outlined a plan to make the tuition for community college free. With this information, we calculated the savings for a 2-year program to be about $9,400 and about $1,300 for a 4-year program. In summary, we first calculated the average length of a college stay to then we calculated the total cost of college without any aid. Then we factored in aid to give the total cost to the student.
Now let's discuss the benefits of different degrees, including the payoffs of STEM, non-STEM, and associate degrees. Here are the assumptions we made for Part 2. An important assumption to note is that we assume taxes to be insignificant. While this is not true in practice, taxes can be mitigated by investing in a home or by saving into tax-advantaged accounts. We decided that the value of a degree is the wealth gained minus the cost of college. Wealth is the lifetime sum of earnings minus the cost of basic necessities discounted to present value. R in the wealth equation represents the annualized cost of capital, or 9.6%. Using the college costs found from the first part, we can now determine the value of an education. And here are the inputs we used for our equations. And then here are the earnings for each degree. And finally, here are the results. It's important to note that the value of a STEM degree is about $320,000, or $329,000, while the value of an associate's degree is only $11,000. This is much less compared to the value of a high school diploma of $72,000. In conclusion, STEM graduates earn by far the most, while graduates with an associate's degree barely have any money to spend.
Part 2 evaluated degrees purely based on their financial benefits and costs. However, jobs should also be evaluated on happiness. This section will also include the non-financial aspects of choosing a career path. We took into account satisfaction, job growth, and risk in determining an overall happiness coefficient. To convert the happiness coefficient to a monetary value, we first converted it to vacation days and then to money. To convert the happiness coefficient to vacation days, it is first rated against its peers in a sample of other jobs. Its percentile is calculated. This percentile is matched with the entry in the top 10 countries of the World Happiness Report that has the closest value. That country's minimum vacation days are then used. For example, a fast food chef with a happiness coefficient of 19.04 is in the 50th percentile and is therefore assigned a value of 25 days. The total value of a job is the converted vacation hours plus the working hours multiplied by the hourly wage. We wrote a computer program to combine income and happiness coefficient into a composite score based on our model. The results are displayed in this graph. For example, less skilled jobs such as cashier and fast food chef attain much lower rankings than STEM jobs such as natural science and other skilled jobs such as dentist.
So the total values here can be used with the model in Part 2 for more comprehensive decision making. One of the weaknesses of the model is that negative growth rates are improperly handled. In fact, more desirable job with a negative growth rate will appear to be less desirable in our model. We could have also used a percentile system to calculate security inputs. In addition, the World Happiness Report consists of many other factors than just vacation time. Instead, we could have used a survey data to create a conversion table. With rising college costs, it caused many people to reconsider their career paths to get the best value for their money. We conclude that a STEM education, while expensive, is the best way to ensure financial security and happiness. Well, ladies and gentlemen, that concludes our presentation. We'd like to thank SIAM and the Moody's Foundation for making this all possible. I'd like to thank our coach, Mrs. Southern, for guiding us along the way. Thank Mr. and Mrs. King for providing us a place to work and a delicious lunch. That was a really good ham sandwich. We would like to thank our very own principal, Mr. Ragon, for making this trip possible and letting us represent South County Stallions. Lastly, we should thank you all for spending your time to listen to our presentation. Thank you very much. Are there any questions?
All right, I think I'll get started. So thank you again for your presentation. The first thing that you just finished up by talking a little bit more about your happiness conversion to monetary values. And I was wondering if you could expand on that just a little bit in terms of how you did choose the parameters that you used to make that calculation. And then, because you did start to tell us a little bit about other things you could have used. Could you share that with us, please?
So we chose risk, dissatisfaction, and job security because these are things that many people fret about every single day. People get workers' compensation, unemployment insurance, and people come back very disappointed some days for work. So these are very core parts of a job. So we use that to calculate a happiness coefficient. The correlation between the happiness coefficient and the number of vacation days, we chose the World Happiness Report because, well, in Virginia it was icy that day, and we planned on doing a survey, really, but, safety concerns. So Our survey would have consisted of questions such as, how many vacation days will I have to give you to make you, say, 5% happier? So we would say, like, scale from 1 to 100, how happy are you, and how much happier would you be if we gave you, like, 7 days more? In terms of the job security inputs, the negative growth rates were improperly handled because of the negative sign on there. We could have converted them all to positive values with a percentile system. It's important to realize that the happiness coefficient, it's not so much as its magnitude than whether it's just greater than another job, because we set them up on a percentile system eventually to compress them down and correlate them with income.
Thank you.
I wanted to talk about a specific table that you had that ended up in the last column with cost of college at some point. So I don't know if you can flip back slides. So this was from part 2, I think, the end of part 2.
And,
Oh, there you go. Okay. I'm just comparing it to the paper. It looks like maybe one of the numbers changed, but the question, it maybe doesn't apply exactly to this table. You had something in here on cost at high school graduation, and then another column that said cost after college. And I was just wondering if you could elaborate, like, what was the difference between those two?
So, in order to factor in the time value of money, college costs after graduation were expressed in part 1, but since we're making the decisions as high school seniors, we need to bring those costs to the present because there's that time in between where stock market returns can be earned. So that essentially is the difference. The cost after graduation is slightly more because that money is future value. So it had time to accrue in the stock market.
Discounted fund. Going to section 1, how would you personalize your model? Here you used average college cost of like $21,000 and so forth. And so if you were to build a tool for an individual to use, how would you personalize your equations here so that to capture that person's unique circumstances?
Well, I would say that given unique circumstances, there's a dichotomy. It is, do you know where you're going to versus if you have like a whole list of colleges. So I'll start first with if you know where you're going to. So every college has estimated tuition. Well, they have tuition, they have estimated room, board, and you know what city they live in, you can figure out how much it costs. And with that, instead of saying an average figure of $19,000 some dollars or $21,000 some dollars, you can plug those costs into the model and it will work out fine. Now, if you don't know where you're going to, you should have a general indication of which part you prefer more, which part you're more likely to get into, and all of that. And from that, you can construct a probability distribution. And you can simply weight the annual costs of each college with the probability distribution to determine a more or less estimate of the annual cost of college, and you can plug that into the model to calculate your costs. I'd also like to add that in the expected financial contributions table, we included multiple earnings figures for households, so you can use like the different figures. So you can use the different values to if your situation is different from the median.
We do one more.
Okay. So, back to your happiness factor. We wondered a couple of things. So part 1, do you think it's possible to find happiness through your career?
Yes, that was actually, I mean, it's complicated because it deals a lot with psychology, right? Some people find even their spouses in a career. So we took into account satisfaction with a career. That was more of just a general blanket for the things in a career because we really could not, given the time, given the constraints, we couldn't just travel around taking surveys of what makes someone happy in a career. So we just used the general satisfaction or its inverse dissatisfaction to determine the coefficient, reasoning that it would, more or less capture all of that.
Okay, so part two, if imagining that vacation is really what matters, so kind of living within the world of your model. So my happiness is going to be equated and from my vacation days. I wonder if you could take into account the quality of that vacation or even your off hours time when you have one career versus another.
Well, if you notice on the slide about the vacation days, there's like a wage, and that, if you, let's say you value going to the Caribbean at a lot because say you were born there or something, you could increase that number and it would change everything. Like, it would change how much the vacation was worth to you, and you could add it together and you would get, again, another composite score.
Thank you.